AI changes the basis of trust. We can no longer assume that people, content, or decisions are genuine just because they appear credible. Digital trust architecture gives enterprises a verification layer that connects identity, provenance, cryptography, governance, and AI assurance into one operating model. Up to this point, we've moved from AI transformation into governance, security, risk, and compliance. Module 6 turns that foundation into technical trust, verifying identities, protecting cryptographic assurances, and proving data provenance so AI systems can be trusted across the enterprise. The old enterprise trust model no longer holds. Content is not reliably human created because text, images, audio, and code can now be generated at scale. Decisions may be made by automated systems we cannot directly observe. And the actors involved are no longer limited to employees or known applications. They include agents, bots, APIs, models, and workloads. As a result, trust must move from assumed and periodically inspected to continuously verified, interaction by interaction. Digital trust architecture is the enterprise system for proving confidence. It connects who or what is acting, what that actor is allowed to do, and what evidence shows the action was legitimate. Traditional trust focused mainly on people and systems. Now it must also cover machine identities, AI agents, generated content, and automated decisions. The goal is to replace assumptions with verifiable evidence. Signatures, certificates, policies, logs, provenance, and governance that make integrity, traceability, accountability, and non-repudiation operational. Enterprise digital trust works as an architecture, not as a single product. Identity proofing establishes who or what an entity is. Authentication and authorization decide whether access should be granted, under which conditions, and with what limits. PKI, certificates, and digital signatures provide cryptographic proof that data and actions are genuine and unchanged. Verifiable credentials and provenance extend that assurance across claims, artifacts, and history. Together, these controls create integrity, security, and audit-ready evidence. Zero trust begins with a direct question: who or what is requesting access? In AI environments, the answer may be a person, application, API, workload, model, dataset, device, or autonomous agent. Each identity needs proofing, authentication, authorization, monitoring, rotation, and revocation. Shared or anonymous accounts weaken accountability and slow investigations. When identity is verifiable, actions can be traced, policies can be enforced, and trust becomes evidence-based rather than assumed. Cryptographic trust moves us from "this looks real" to "this can be proven." A digital signature shows that a message or artifact was signed with a trusted private key. A certificate connects that key to a real identity. Encryption protects what must remain private, while hashing helps detect tampering. In AI environments where fake content can appear convincing, cryptographic validation provides stronger evidence than appearances or manual review. Trust minimization starts with one practical assumption: nothing is safe simply because it looks familiar. A realistic video, an internal AI agent, or a connected API still needs verification. Check identity, source, permissions, provenance, integrity, policy, and logging before granting trust. Then limit the impact if something is wrong through least privilege, segmentation, scoped credentials, and continuous validation. The point is not zero trust as a slogan. It is reducing automatic trust everywhere. Identity-first security makes the actor the starting point for every access decision: a person, device, workload, or AI agent. The system then adds context, such as role, behavior, device health, location, and risk. Only then does policy decide what is allowed, denied, or limited. This matters because AI agents can operate across APIs, cloud services, and data stores. Binding permissions to identity makes zero trust enforceable, audits clearer, and containment faster. Consider an audio message that sounds like the CFO approving an urgent payment. The risky response is to trust the voice because it feels authentic. Provenance changes the decision. We verify the sender, check whether the file came from a signed source, inspect creation and modification history, confirm through a trusted channel, and log the evidence. Authenticity is not judged by realism. It is earned through traceable origin, custody, and verification. Machine identity governance controls every non-human actor that can access systems: AI agents, APIs, workloads, model services, pipelines, and robots. In many enterprises, these identities already outnumber people. If service accounts, keys, certificates, or secrets are unmanaged, they become easy attack paths. Each machine identity needs an owner, a clear purpose, scoped permissions, rotation, monitoring, and fast revocation. Treat them as first-class identities, not background technical details. Trust architecture only works when it is governed as an enterprise capability. That means assigning real owners for identity platforms, PKI, certificates, signing keys, agent identities, and provenance services. Policies then define how credentials are issued, verified, rotated, and retired. Risk and compliance teams align these controls with AI governance and audit requirements. Metrics make trust measurable: expiring certificates, unmanaged identities, rotation compliance, exceptions, and provenance coverage. In the AI era, trust cannot depend on appearances. Sign and verify important identities, actions, and artifacts. Check who or what produced content before accepting it. Validate provenance whenever content may be synthetic. And never allow autonomous agents to operate without accountable, revocable identity. The target state is not a single trust tool. It is an enterprise trust fabric that connects identity, cryptography, machine identities, provenance, and assurance. Policies are centralized, while enforcement happens wherever AI operates: data pipelines, models, agents, applications, APIs, and cloud services. Each action can be verified, logged, and tied to evidence. That evidence supports audit, SOC, risk, compliance, and AI governance, making trust measurable across the lifecycle. The core takeaway is simple. In AI-enabled enterprises, trust cannot be assumed from appearance, behavior, or authority alone. Identities, machine actions, content, and decisions need cryptographic verification, provenance, and governance. Next, we build on this foundation with AI agent trust, verifiable credentials, deepfake resilience, and post-quantum readiness.